Good evening everyone. Welcome to one concept per day portal. And today's concept that we are going to discuss is about the magnetic forces. Forces acting on a current carrying conductor either to an applied magnetic field or maybe due to two parallel conductors. What is the force acting? That's what we are going to look into it. Okay, so now let us begin with this. This question is being taken from the paper M02, that is May 2002. Okay, now let us begin with this question. The diagram shows a beam of charged particles moving in a straight line with speed v. Each particle has a charge plus q and there are n particles in length L of the beam. There are n particles over here. It's moving like this with a velocity v. How far do the particles travel in time delta t? Okay, this is a problem coupled with magnetic field along with the mechanics. So you can just say if delta t is known and v is known to you, then the length distance traveled L is equal to v times delta t. Very easy question. Okay, velocity times delta t, because it's not accelerating, right? It's only moving at a uniform speed, so you can write like this. How many particles pass a given point in a time delta t? Okay, that's how many particles are moving in this. So towards it, what we do is, he says there are n particles in length L. That means I can now write number of particles in length L are per unit length. Instead of writing in length L, I can say per unit length is equal to n divided by L. Okay, so n divided by L. Let us say the length is something like around 5 centimeter. Okay, and there are 50 particles over here. Now what I do is I want to find out what is the number of particles in 1 centimeter. What do? I just did 50 divided by 5 centimeter. That's what I have done over here. Okay, and now this length passes a given length L over here. So therefore, so how many particles pass a given point in a time delta t? In a time delta t, this n by L multiplied by the length that we have. What is the length over here? Length is v delta t over here. Okay, this n by L into v delta t is nothing but the number of particles. Note that here this v delta t is nothing but length over here. This L is the actual length over here. So this much multiplied by this will give you a total number of particles that has passed a given unit of time. Okay, next. Using your answers to A and B above, show that the current I carried by the beam is given by the expression. Now, what is that we have seen? So, there is a point P over here. So, how many particles are crossing over here? There are n. What is the particle? How many particles are crossing over here? It is already given here. It is n divided by L into v delta t. This is the number of particles. Okay, I can say this is 50 particles, 80 particles, 90 particles, something I can tell number. So, these number of particles have crossed over here. Now, what is current? Current I is nothing but total charge crossed divided by in what time it has crossed. Right? Now, if I want to get the charge over here, now let me assume, for example, if there are only two charges crossed, okay, only two, number 2 I am telling you, number 2 charges just crossed. What is the amount of charge that has passed through it? I can now say, see, what is the value of one charge plus q? So, I can say 2q has charge over here. Okay, so it has crossed, only two charges have crossed, which means I can say 2q is the total number of charges which has crossed over here. If suppose if this is 4 charges have crossed, then what can I say? I can say 4q is the total charges being passed. Now, if this much amount of charges has crossed, what should I say? Now, I should say that the total charge cross here is nothing but multiply this by q, right? Multiply this by q. So, therefore, I am going to write this as n by L into v delta t into q divided by this delta t, because charge by time, right? So this delta t goes away. So thus I am now left out with q v n divided by L. Did we arrive at the same equation? We arrived it. Okay. Now let us move on to the next one. When the uniform magnetic field of strength B is applied at right angles to the direction of motion of the particle, each particle experiences a force of BQV. Okay. So now if you apply a field perpendicular to it, it will experience a force BQV. If the direction of the field is into the plane of the paper shown on the above diagram, the direction of the magnetic force on one of the charges. Now it says magnetic field is into the plane of the paper. So how does it look like? It looks like this over here. Now if you have something like this, then what would be the force acting on these charges? So what you need to do? Use your finger rule. Okay, so this is your magnetic field is directly. It's been pointing inwards, and then positive charges, motion of positive charges is nothing but current. Okay, so it is now moving like this over here. and as a result of this, force would be upwards over here. Okay, so force is upwards over here. So either you can write like this, or you can also write here that the force is upwards. You can write like this also. Okay, next. Show that a force BQE on each particle is equivalent to a length L of the beam experiencing a force of magnitude BIL. So we need to show the total force acting on it is equal to IBL. Okay, where have you learned this BQE and BIL? You already learned. This is the force, magnetic force acting on a charged particle. This is the force which is because of the current which has been flowing through a wire. Okay, now how do we show this? Now towards it, what we do is, let me take up the current I here. Current I is equal to QVN by L. Let me write it down here. Current I is equal to QVN divided by L. Okay. Now the force acting on it is equal to BQ into V. So towards it, now what do I have here? I have QV here, and I will write this as, this is due to one charge. Okay, you have one charge. If the number of charges passing through it per second is equal to this much, there is a number of charges over here. Number of charges is nothing but N by L into V delta T into Q. Okay, so therefore I will now write this as, I'll write V as such over here. Now this number of charges, which is nothing but N by L into, just a moment, I can write, sorry, I'll not write this. Okay, this is the force due to one charge. If there are n charges crossing over there, I can now write this as Fn is equal to NBQV. We can write like this over here. So now we already know I equal to QVN divided by L. Where is it? QVN, there is no L here. So what I will do is, from this equation I will write QVN is equal to I times L. From this equation I will push this L that side, I get I into L. So now here what I can do, I can now write this as this QVN, I will group this B into QVN, I will write like this over here. And then again what I will do is, I will write Fn is equal to, this QVN is equal to IL, so I will write B into I into L. So finally we have got the expression what has been asked over here. Okay, now let us move on to the next one. The diagram shows two parallel wires X and Y carrying equal currents in the same direction. Okay, it's been given over here. Let the current be I. It says equal currents. So therefore I'll put I is equal to I here. Ix equal to Iy equal to I. Okay. On the diagram, show the direction of the force acting on each wire. What is the direction of the force? Since there are two parallel conductors and the currents are moving in the same direction, the current will be acting like this. So the force will be acting like this. Force here will also be attracting like this over here. When two parallel conductors have currents in the same direction, then the forces between them is always attractive. Okay, so therefore it is attractive, so it will attract like this. Next, we have done this. The current in each wire is 2 ampere and the wires are 0.5 meter apart. This is a little bit different. So I is equal to 2 amperes and the distance between the two wires D is equal to 0.5 meter. Okay, and now what has been asked? Calculate the magnitude of the force exerted per unit length. He is asking you to find out what will be the value of force per unit length. Okay, so this was there in the previous syllabus. In the current syllabus, they can ask you, but they need to give you one more data over here. The data is that they should provide you something like the magnetic field due to a current carrying conductor, infinitely long current carrying conductor, is equal to mu naught times I divided by 2 pi r. This information should be given to you. Okay, it will be given. If suppose if this question, similar question was being asked, they will give you something like this, where r is the distance of the point, where your magnetic field is to be determined, where the magnetic field is to be determined. If suppose if this is given, okay, then this question is really valid. You cannot say it is out of syllabus. Okay, earlier, so we had this one, but now we do not have this. Okay, but that doesn't mean that I cannot ask you this question. We can still ask you. provided appropriate information should be given to you. This information should be given to you. Okay, let me imagine that I have given you this information also. Okay, when I give this information, now what does it tell you? See, why does this wire get attracted? The reason is because this is now passing a current, and because of this current, now this is producing a magnetic field, right? How is the magnetic field produced? See, a current carrying conductor is now making a magnetic field to go inwards. Okay, it's going inwards like this. So as a result of it, so you are having magnetic field everywhere over here like this. You are having magnetic field here. Why did this magnetic field arise? It's because of the Ix over here. Because of the Ix. So what is the value here? It is nothing but Bx over here. Let me take Bx over here. Now if I ask you what will happen to this conductor, this conductor will experience a force. What is that force value? That force value is nothing but Fy. I'll write Fy is equal to Bx into Iy. This is your Iy into Ly. This is what I should be getting over here. Okay, this is nothing but the force acting on the second conductor due to the magnetic field generated by the first conductor. Okay, this generates a magnetic field, and therefore a current carrying conductor Y, when placed in an external magnetic field. Which is the external magnetic field? The one which is due to X, okay, produces a force, okay, or experiences a force, and this force is directed like this, given by the left hand rule. Okay, now what we do is, we have already written this equation, Fy equal to Bx Iy Ly. I'll write down that Fy is equal to Bx Iy Ly. I've written this, and already this Bx, what is the magnetic field? I want to find out the magnetic field at this point. This Bx, we already know it is given by Bx according to this formula. It is given by mu naught. And what is this I? I is nothing but Ix, the current carrying conductor. Ix divided by 2 pi, and what is this r here? This distance d. I substituted for Bx, and then I will write Iy, and then I will write Ly over here. Okay, when I do this, what is that I get? We know that Ix is equal to Iy. Ix is equal to Iy is equal to I. Let me substitute all of them. So I get mu naught I into Ly divided by 2 pi d. I get this value. Then once again what I will do is, I will multiply this, I'll simplify this one, so which should now be equal to, okay, I'll take it right like this here. I'll write the, what is this now we have, this is your force, sorry. This is your force. Which force is this? Fx over here. Fx over here. Fx or Fy? This is Fy, I'm sorry. This is your Fy over here. Fy is equal to so much. And once again write this as Fy is equal to, now I have mu naught I square Ly divided by 2 pi d. Now what do I need? I need this Fy divided by L here. I will take Fy divided by L is equal to mu naught I square divided by 2 pi d. Now I have arrived at a formula over here. Let us substitute the value from the data booklet. The value of mu naught will be 4 pi into 10 to the power of minus 7 multiplied by current. What is the current here? 2. So therefore 2 square becomes 4 divided by 2 pi multiplied by, what's the value of d? D is distance between the wires, which is 0.5. Okay, now let us solve this. What do I have here? I have 2 pi 1s are 2 pi 2s are 2 into 4 8 divided by 0.5. Right here 8 divided by 0.5 into 10 to the power of minus 7. See, is it minus 7? Yes, minus 7. So which should be 1 by 5, 0.5 is 2. So finally I can write this as a 16 into 10 power minus 7, or 1.6 into 10 to the power of minus 6 Newton. Okay, Newton. And what's the unit? Newton per meter. Why per meter? Because you know, here I have taken Fy divided by L over here, right? Look at this over here. This is Fy divided by L. That's the reason why this Ly came downwards over here. Ly came downwards, and that's what we got. What is that we require? We also require the same thing. It says magnitude of the force exerted per unit length of each wire. Okay, so don't assume, okay, these kinds of questions may not come. Okay, they may also come, provided that at the same time this information would be given to you. Okay, next, let us move on to the next one. Suppose that Y is free to move. Describe and explain the subsequent motion of the wire Y in terms of its velocity and acceleration. What is happening over here? This is X, this is Y. This is X and this is Y. Initially I said they are fixed. Now I say, okay, they are free to move. Okay, this is fixed, y is free to move. So what will happen? This is now introducing a force over here. It is now trying to grab this like this. Okay, now it comes like this. The first one, what happens? Y moves towards x. The second one, what will happen? Now, as let us say, for example, when it comes over here, now the value of d is decreasing, right? So earlier this was d, and now the value of d is decreasing. When the value of d decreases, now let us look at what is the force over here. See, this Fy by Ly is proportional to 1 by d. Current is not changing, 1 by d. Which means when denominator decreases, then this quantity will increase, right? Will increase. So therefore, what will happen? The force will increase. When the force increases, what will happen? The acceleration increases, right? Then when the acceleration increases, what happens? The velocity will also increase, right? The velocity will also increase. Then anything else happens? Nothing else happens. So this is what happens until here. Okay, so you need to describe the subsequent motion of y in terms of velocity and acceleration. Yeah, describe all of it, right? So I think with this we come to an end to this particular problem. Let us see the next problem in the next video. Thank you. And if you want this question paper is available in my WhatsApp group. You can join my WhatsApp group to get all the further updates, because exams are coming nearby. I'll be posting a few more materials onto it. So don't forget to subscribe my channel. So I will also be posting the same thing in my channel also. Okay, and then my URL for the WhatsApp group is https://rebrand.ly/IB physics with Rao. Okay, the same URL, that is, if I have IB, if you just go to Google and type it as IB physics with Rao, you'll get all the links. All these links, okay, correspond to me itself. I have the links correspond to my website. My website is nothing but ibphysicswithrao.com. You also have links for Facebook, LinkedIn. You can follow me in any of the social media, so that as I post one video, okay, the information regarding this will also be posted correspondingly into these videos. Okay, this will really help me out. Okay, it will really help you out to get updated. Okay, thank you.